So when you hear electrostatics, you need to know this talks about this branch of physics that studies charge at rest, and positive charges point outwards, while negative charges point inwards. So when you bring a positive and a negative charge, they'll attract, because this one points outward, while this one points inward. They'll attract. But when you bring a positive charge and a positive charge, this one points outward, this one points outward, this one points outward, this one points outward. So they will repel. Like charges repel, unlike charges attract. Electrostatics. So we can't talk about electrostatics or electricity without talking about Faraday coulombs. Now, Faraday said that the force of attraction between two charges and distance apart can be measured. But it was coulombs that stated this mathematically by saying that the force of attraction is directly proportional. Force of attraction between two point charges is directly proportional to the charges and inversely proportional to the square of the distance apart. So that's Coulomb's law, and this is the same thing as F equals to K Q1 Q2 over R square. And you need to know that K is some kind of constant, and K is equals to 1 over 4 pi epsilon 0, and this is same thing as 9 times 10 all raised to power 9. You need to know that. Now, electric field intensity. Electric field is intensity. So you need to know this simply. You need to know that the force per unit charge is equals to electric field intensity. So electric field intensity equals to force per unit charge, and you know that force itself is equals to, can represent force as KQ1 Q2 all over R square, so divided by Q. So this is the same thing with this, and you know that this is the same thing as so electric field intensity is force per unit charge. You need to know that. Electric potential voltage. Now you need to know that electric potential voltage, in simple terms, the work done in moving a unit charge from infinity is called electric potential voltage. But this is kind of a long way of explaining it. Simply, you need to know that electric potential voltage is simply charge per unit, charge per square distance. Energy potential voltage is simply charge per square distance. So E P potential V is equals to charge per square distance. Charge per square distance. So charge per square distance. So if you know this, you also know the last one, which is the next topic. Because our next class, what I want us to do next class is to solve questions on electrostatics before doing capacitors in series and in parallel. But you just need to know that if this is so, capacitance is simply charge per potential difference, that is per voltage. So charge per unit volts is capacitance. So they are related when you know that this is per this one, this is per this one, this one is per this one, this is per this one.